Hello and welcome to episode 11 of Cloud Tech 10 for the 22nd of May 2017. I'm Mark and I'm going to tell you the latest news about Microsoft Azure from the past week in 10 minutes or less. AzCopy, the command line utility for copying large amounts of data to and from Azure storage accounts, is now available in preview for Linux. AzCopy has been rebuilt using .NET Core, so to use it you'll first need to install .NET Core for Linux. The exact steps of doing this vary by Linux distribution and full instructions can be found at this location. Once .NET Core has been installed, it's simple to install AzCopy. Download the installation source using wget, then unpack the files using tar. Then run the install script and you're ready to go. AzCopy is useful in a number of different scenarios and is designed for copying large amounts of data. A typical use is copying virtual hard disk files to Azure. I've got a VHD file that I want to copy to my Azure blob storage. To do this with AzCopy, I provide the details of the source directory and file. In this case, it's just one file, but AzCopy can also handle copying multiple files. Next, the details of the blob storage container that I want to copy the VHD file to, and finally, the access key. AzCopy is designed to provide high performance, so my upload, which in this case is 1 GB, completes quite quickly. Azure Cosmos DB has added a preview of per-minute provisioning. Cosmos DB has the concept of request units. To provide predictable performance, you reserve Cosmos DB throughput by specifying the number of request units your database will consume per second. A request unit represents the compute time that a database operation, such as a read or a write of one or more documents, or a query for a specific subset of documents, will consume. One request unit is roughly equivalent to making a direct request for a specific document of 1 KB in size. However, as Cosmos DB is designed to be highly efficient, it doesn't automatically equate that a 100 KB document or 100 1 KB documents would equate to 100 resource units. In fact, it's generally significantly less. The Azure portal tools for Cosmos DB will give you details of how many request units an operation on your database has consumed, as well as providing metrics to show overall utilization. The SDK for Cosmos DB will also return the number of request units consumed for each operation. And there's the Cosmos DB calculator that you can use to help estimate how many request units you may require. Once you've estimated the usage, you configure Cosmos DB to reserve a number of request units per second. If you happen to exceed the number of reserved request units, you'll get a warning message from Cosmos DB indicating that you're being throttled and need to wait and retry the operation. This means that if you have an application with spikes or bursty behavior, you may find yourself going over your reserved request unit limit on a frequent basis, requiring database operations to be retried. If performance is important, then you may find yourself reserving more request units than you need on average in order to cope with unexpected spikes. Request unit per minute provisioning helps to solve this problem. When enabled, you can reserve 10 times the currently provisioned request units per second as request units per minute. So if you currently reserve 1000 request units per second, you can have 10,000 request units per minute. So every 1 second you get 1000 request units. If your application experiences a spike and uses 1300 request units in a second, normally that would have resulted in throttling and performance degradation. But with request units per minute, the 300 request units over the 1000 are taken from the 10,000 request units per minute, leaving that with a balance of 9700. Over the remainder of the minute, other requests may generate spikes and anything over 1000 will be deducted from the per minute reservation. At the end of the minute, the reservation is topped up again to 10,000. Previously, to avoid throttling, I would have had to reserve enough per second request units to handle any spikes, meaning I would likely be paying for a lot of unused capacity when workloads were operating normally. Request units per minute allows me to save money by not reserving more throughput than I need for typical usage, whilst still being able to handle spikes without any performance penalty. The number of Microsoft Cloud regions worldwide grew to 40 this week, with the announcement of planned new regions in South Africa. Data centers located in Johannesburg and Cape Town will provide Microsoft Cloud services, including Azure, Office 365 and Dynamics 365. The new South Africa region will be available for use in 2018. New Windows Server images have been added to the Azure Marketplace with smaller operating system drives. Managed disks were introduced earlier this year, and these help reduce the overheads associated with the creation and management of disks used by virtual machines. Managed disk pricing is based on the size of the provisioned disk. There are 3 price tiers for premium managed disks and 5 for standard managed disks. Until now, the standard size for a Windows Server OS disk image from the Azure Marketplace was 127 GB, placing you straight into the S10 or P10 tiers. The new smaller operating system drives are provisioned at 30 GB, allowing standard managed disks to take advantage of the lower cost S4 tier. For a single managed disk, the price difference is only a few dollars, but if you're deploying a large number of virtual machines or using virtual machine scale sets, then these smaller operating system drives could add up to more significant savings. If you later find you need more than 30 GB, then you can resize the disk using either PowerShell shell or the Azure CLI. To do this, first you need to deallocate the virtual machine. Next, I use the disk list command to find the name of the managed disk that I want to expand. The name of the managed disk is here. Next, I update the managed disk and specify the new size, in this case 100 gigabytes. And now I just restart the VM. Once the VM has restarted, I can see that its operating system disk has now grown from 30 gigabytes to 100 gigabytes. And all I need to do to make use of it is to extend the volume using the disk management tools in the operating system. That's all for Cloud Tech 10 this week. Don't forget, tell your friends, like, share and subscribe, or follow me on Twitter. I'll see you next week. Cheers for watching. Thanks for watching. If you enjoyed this video, don't forget to like, share, subscribe and follow me on Twitter for more.